Hello everyone, it's me Amna and welcome to Amna's Learning Hub. I hope you all are fine and following my videos and it is helpful for you. Okay, so we were discussing chemical bonding. It is our third lecture of chemical bonding. I hope you all must have seen the second and first lecture of this chapter. So in this chapter, we are talking about the bonding. Like we discussed about ionic bonds, we discussed about covalent bonds, and we also discussed about the properties of ionic and covalent compounds and what type of compounds they are. Now in this lecture, we are talking about metallic bonding and we will talk about the properties of metals, right? And after that, I will give you a brief introduction about coordinate covalent compounds that are also called dative bonds or dative compounds. So, in metallic bonding, as I previously told you that we know in every metal, suppose this is the surface of metal, and in metal, we know there are so many protons, and then we have sea of free electrons. First thing is, in metal, you have so many protons and you also have sea of electrons, delocalized electrons or a number of free electrons. You can use three terms. One is sea of electrons. Then we can use free electrons. Another term is delocalized electrons. Now, the main thing which you must know about the metallic bonding is the bond which is formed between these protons and these free electrons. When any free electron come close to any proton, there is the formation of bond which is called metallic bond. And this bond is quite weak. Inside the metal, the metallic bond is quite weak because the electrons are continuously moving, and when one electron comes in contact with any proton, they form a bond, and that bond is called metallic bond. Now, the very important question is how delocalized electrons formed. How delocalized electrons form. This question is very important because whenever we study about metallic bonding, the thing which instantly comes in our mind is how these electrons are free now, how they moved out of their outermost shells, and how they are not in the contact of any proton permanently. So to answer all these questions, I am telling you about the concept of delocalized electrons. So, in metals, in any element, we have a central nucleus. Then we have first shell which has 2 electrons. And then we have second shell which has 8 electrons. 1, 2, 3, 4, 5, 6, 7 and 8. Then third shell, then fourth shell and so on. If we talk about the metals, the structure or the atomic size of metals are very large. Atomic size means the size which we calculate from the center of the nucleus to the outermost shell. This distance is called atomic radius, and the whole the circumference of the whole atom is called atomic size. So when the number of shells are constantly increasing, the atomic size is also increasing. So this is the nucleus in the center, and nucleus has attractive force in it, and nucleus attract all the electrons towards itself. When there are so many electrons between the nucleus and outermost shell, for example, this is another shell that I'm making. Now, this is the nucleus, this is first shell, second shell, third shell, fourth shell and fifth shell. For example, fifth shell is the outermost shell. So, nucleus is attracting the electrons which are close to it, and as the electrons are moving away from the nucleus, the inside electrons or inside shells cause an effect which is called shielding effect, shielding, shielding effect. That means they are shielding the attractive force of nucleus towards the outermost shell or the electrons of outermost shell. So outermost electrons have less nuclear pull on them. That is why they instantly removed from their shell, and after moving out of the shell, they started moving here and there without any nucleus, without any permanent nucleus. That is why they are called free electrons or delocalized electrons, or the pool or sea of electrons form in metallic bonding. I hope this question is clear to you all, that how delocalized electrons are formed. First thing is, the metals have very huge atomic structure, very big atomic size, due to which the nuclear pull towards its outermost electrons decreases because of the shielding effect. Shielding effect is because of the number of shells which are present between the between nucleus and outermost shell. Between this nucleus and this outermost shell, these shells are creating a shielding effect. They are behaving as a shield, so they are decreasing the attractive force of nucleus towards outermost electrons. That is why the outermost electrons have very less attraction of the nucleus, and they leave the outermost shell and start moving here and there. That is why they are called delocalized electrons. So this was all about metallic bonding. Now we are going to study about the properties of metals. Okay, so properties of metals. Point number 1 is high melting and boiling point. MP means melting point and BP means boiling point. Metals have high melting and boiling point because metals are usually in solid form, and we know that solids have high melting and boiling point. Number 2, metals are malleable and ductile. So malleable means they can be drawn into sheets, and ductile means drawn into wires. That means we can convert the metal into sheets or into wires. For example, we have some surfaces of iron or aluminium. We have aluminium roofing, we have aluminium walls, we have aluminium windows. So that means aluminium is a metal and we are converting into sheets. Another thing is, we use electric wires which are usually copper wires or which are iron wires sometimes. So copper wires, copper is a metal and we convert that copper into wire. Now what is the concept behind this malleability and ductility? So understand this. This is the metal and it has so many protons and it has free electrons. So this is the surface of metal before applying any force. You can see all of the protons are layered over each other. So when we apply some force, for example, this is here, I applied some force with the hammer or with any heavy thing. I applied some force on the surface of metal. Now these protons are slide past over each other, right? Here the protons are above on each other, and here when we applied some force, this middle layer of the protons are slided past over each other. and this sliding path is deforming the surface of metal. For example, this is the metal and I hit the metal, and when I hit the metal, the one layer of the protons is slide past. So when one layer is sliding past, so it is deformed. The shape is changed. So when we continuously hammer it, so shape will be changed and all of the layer will be slide past, and then it is converting into wire, or it can be converting into sheet. That is why the metals are malleable and ductile. And first property I told you that they have high melting point and boiling point, as well as they have high density. Density means there are more atoms, there are more protons per surface, per unit area, right? So in the form of gases, as I told you, this is a solid, and solid has more atoms in less surface. Atoms are quite close to each other. That is why it has high density, high melting point, high boiling point, and high density, right? Third property of the metal is they are good conductors of heat and electricity. We discussed about the conductance of electricity, that how electricity conducts. So, here we talk about good conductors of heat and electricity. Now, what causes the conductance of electricity? We know the structure of metal. It has protons, so many protons, and so many free electrons. So when current passes through it, we know that current is also composed of electrons. So when current passes through it, these oppositely charged ions or the electrons causing the current to pass through it. That is why they are very good conductors of electricity. Sometimes we see that if someone holds a wire, so it get electric shock, because our body also has electrolytes, our body also has oppositely charged, our body also has salts. So whenever oppositely charged liquid or oppositely charged aqueous solution or oppositely charged metal is getting connected with any electrical device, so it will eventually start passing current through it. That is why metals are good conductors of heat and electricity. With this chapter is complete. Let's have a review of this chapter. We talked about chemical bonding. Bonding is the attractive force between the atoms, between the molecules, so between the electrons and the protons in the case of metallic bond. Then I gave you examples of then we discussed the types of chemical bonding. We discussed about ionic bonds, covalent bonds, metallic bonds, and I am going to give you a brief idea about coordinate covalent bonds. So in ionic bonds, we discussed how cations and anions are formed, how they both come close to each other and form a bond, and that bond is called ionic bond. In covalent bonding, we saw that elements share their electron to complete their outermost shell. In metallic bonding, we observe that protons and freely moving electrons make an attractive force between them, that is called metallic bonding. And then we discussed about the properties of metals, that they have high melting and boiling point, they have high densities, also they are good conductors of heat and electricity, and they are malleable and ductile because they can be drawn into wires or they can be drawn into sheets. That was all from this chapter. That is all for the O levels chemical bonding. Then coordinate covalent bond. Just a brief idea about coordinate covalent bonding. So the word coordinate, whenever the word coordinate comes, that means there must be a coordination, there must be some pair, there must be some two things. So coordinate covalent bonding. If we break this word, so covalent bonding is because of which is sharing of electron, and coordinate means in which two electrons are involved. So when a complete pair will be shared with other molecule or other atom, this type of bond is called coordinate covalent bond. For example, nitrogen, it has 5 electrons, 1, 2, 3, 4 and 5. It is forming, nitrogen is forming 3 bonds with hydrogen, 1, 2 and 3. This is hydrogen, this is hydrogen and this is hydrogen. Here we also have some in reinforcement. For example, this is dot and cross structure, right? Dot and cross structure, and this bond is covalent bond because sharing is happening. So this one pair is called lone pair. Lone pair. That means this one pair of electron is not forming any bond with any other atom. So this is called lone pair. Now we have hydrogen atom. Hydrogen atom H plus, which has no electron in it. Hydrogen has 1 electron. After donating that 1 electron, now hydrogen is deficient of 2 electron and there is no electron in hydrogen. So this whole NH3 will be give its lone pair, and when it gives this lone pair to this hydrogen, it is forming a coordinate covalent compound. So this is called lone pair, this is called bond pair. Okay? This is a donor because it is donating electron pair, and this is called acceptor because it is accepting electron pair. So this whole bonding is known as coordinate covalent bonding. With this, today's chemical bonding chapter is over. In these 3 lectures, you will understand types of bonding, how they forms, what are their properties, and how can we differentiate from one from another, right? I will share a reel in which I will explain you the difference between all these 4 types of bondings and will give you some examples. Thank you so much for seeing my lecture. I hope it will help you, and if you have any question, you can message me on Instagram and you can comment me on my videos so that I can resolve your query. On Instagram story, I will upload questions regarding chemical bonding because we are done with the chapter, and after completing the chapter, I always upload questions, P1 like MCQs type questions, P2 which are detailed answer questions, and then some if some chapter is related to the practical part, I upload those questions as well. So stay tuned and get the questions from Instagram and practice the questions, and if you find any difficulty, you can message me and you can ask from me. Thank you so much and take care of yourself. Allah Hafiz.